Welcome back. In this video, we will be focusing on cylinders. So cylinders are surfaces in the 3 space, and a cylinder consists of lines that are called rulings, and these lines are parallel to each other. Then that they are parallel to a given line, and all these lines they pass through a given plane curve. So as an example, let's look at this surface. Think of like a pipe and the surface of a pipe, a circular pipe. So that's what I have here. So the green curve here, imagine that that's a curve in some plane, and then you have this rulings in pink. These are straight lines that pass through the curve and that are parallel to each other. So this straight line, so the surface here consists of this straight lines. So that's what a cylinder is. Let's look at this equation. Z is equal to x squared. This is an equation in x, y, and z in the 3 space, and we want to know what's the graph of that. Now the graph of that is a surface in the 3 space. And to understand what is this surface, we will be looking at traces of this of the graph of this equation. Now, which trace am I gonna look at? Well, the trace that I'm gonna be looking at is the traces that I'm gonna look at are the traces that are parallel to the xz plane. That is, since you see that y is missing here, so no matter what I set y to, I'm going to get the same equation. So that tells me that the trace in the plane y is equal to k is the parabola z is equal to x squared. Now recall that y is equal to k, that's just a plane that is parallel to the xz plane, and it passes through the point 0, k, 0. So that is when k is 5, I'm going to get a parabola z is equal to x squared in the plane. So the trace in y is equal to 5 is the parabola z is equal to x squared. That is, it's a copy of this parabola in this plane. So this is the trace in the plane y is equal to 5. This is the trace in y is equal to 0. Y is equal to 0 is just the xz plane, and the trace in y is equal to -5 is here. So this is again at y is equal to -5. That's the plane that is parallel to the xz plane, and it passes through the point 0, 5, -5, 0 here. So this is the y-axis here. The dotted one is the x-axis, and then this is the z-axis. Now the question is, so understand that no matter what k is, then we get a parabola that opens in the positive z direction in this plane. So basically the traces parallel to the xz plane are all the same parabola here. So imagine that you have the parabola, you have the trace in this plane. Now as k goes from -infinity to positive infinity, imagine that these parabolas, you are moving them from the negative y direction to the positive y direction, and as you move these parabolas, they are sweeping through the surface. That's the graph of this. So the graph of this guy would be something like this, and this is called a parabolic cylinder. Okay, so it's kind of to kind of imagine how it looks like. Imagine that you have a you have a you have a you have a a pipe, and let's say a circular pipe, and you cut it in the middle, and then you get something of this shape. So again, this surface goes to infinity in the positive z direction, and it also goes to infinity in the positive y and negative y direction. It also goes to positive. It goes to infinity in the positive and negative x direction as well. So the way I see it, I'm going to say that this is a parabolic cylinder that is extending along the y-axis. Let's look at another example. Let's say I have the equation y squared plus z squared is equal to 1, and what's the graph of this equation? Anytime you have an equation in the 3 space where one of the variables is missing, you will be getting a cylinder. So in this case, I'm going to look at traces in planes given by equations x is equal to k. So I'm basically looking at traces in planes parallel to the yz plane. So for example, when k is 0, I am getting, if I plug in x is equal to 0 here, well, it is still the same equation. So this equation is a circle of radius 1 in the yz plane, centered at the origin. So when x is 0, I'm getting this circle in the yz plane. When x is 3, I'm also getting the same. I'm also getting a copy of the same circle in the plane x is equal to 3. So this is a plane. This trace is in the plane parallel to the yz plane, passing through the point 3, 0, 0 here. So the traces. So you can see that all the traces parallel. So imagine this. That when x is 0, this is the trace that I'm getting, and then as you change k here, the traces parallel to the yz plane, you can move. So imagine that you're moving this circle in this direction, so you're sweeping through a surface as you do that, and also in the negative x direction you do the same. So what you're getting then, is a cylinder. In this case, this is called a right circular cylinder because in this case you have this circle here, and then the surface consists of straight lines passing through this curve and perpendicular to the yz plane. So this is a right circular cylinder. Of course, this is a cylinder that is extending along the x-axis. So along the x-axis it goes from negative infinity to positive infinity. Okay, so the graph of y squared plus z squared is equal to the graph of this equation here is a cylinder. Now, if I have instead of z here, if I have x squared plus y squared, then I'm also going to get a cylinder, but in that case the cylinder is going to open in the is going to extend along the z-axis. See, again, if I replace z by x, then I'm going to get again a cylinder where the cylinder will extend along the z-axis. So notice that when you have cylinders given by equations where one of the variables is missing, so here y is missing, and then the cylinder is extending along the y-axis. Here the x is missing, so you see that the cylinder is extending along the x-axis. So this is a this one in the, if I just focus on YZ plane, this is the circle, and then anytime I look at the trace in any plane parallel to the YZ plane, I get the same circle. So we get this cylinder. Okay, so that's all I want to say about cylinders. Okay, so there's one more thing I want to say, which is, what if I have an equation, let's say, so let's say I have an equation like this one. Say, let's say y is equal to x, and this is an equation that I am. So I'm thinking of this as an equation in the XYZ space, so that is in the 3 space. So z is missing here, but the graph of this equation in the XY plane is a straight line, right? So then what's the graph of that in the 3 space? Well, then what you're going to get, you're going to get a plane that is that's gonna pass through this this line, and it is perpendicular to the XY plane. Okay, so I'll stop the video here, and in the next video we start talking about quadric surfaces.